Hi everyone, in this video we're going to go through 6J, the tangent function. So we've covered sine and cos in a lot of detail, but poor tan is left behind. So it gets a video on its own, but it is different to sine and cos. So you can see on the screen there is a tan graph. Okay, so it clearly looks different to a sine graph and a cosine graph, which look the same. So whenever you see a graph like this, you should automatically know that it's going to be a tan graph. Now, with tan graphs, because tan theta is, whoops, let me just get my highlighter. Tan theta is equal to sine theta over cos theta. And we covered that at the start of circular functions. So if you're a bit unsure about that, go back and have a look at your notes on that when we started circular functions. So because cos is on your denominator and we can't divide by 0, okay, so wherever cos is equal to 0, it can't equal to 0 because it's on the denominator, we actually have a asymptote. So you can see here it says undefined, and that's because cos of pi on 2 is equal to 0. And we have it here as well, undefined, undefined, and undefined. All right, so your asymptotes on your graph, they're already on there, but I'm just going to highlight them in green. Okay, so you don't really need to know these numbers off by heart, but you should also know when cos is 0. Okay, so pi on 2, negative pi on 2, 3 pi on 2, 5 pi on 2. And then because your tan graph, just like sine and cosine go on infinitely, you can have infinite asymptotes. Okay, so we're only going from negative pi to 3 pi in this graph, but you can actually have infinite asymptotes. All right, the other important thing you need to know when drawing a tan graph is the x-intercepts, or in this case theta intercepts, because we're working with theta. So here it is here at negative pi, here at 0, here at pi, here at 2 pi, and here at 3 pi. And they're also on this table. Okay, so you can see them clearly marked here. All right, and basically that is when sine theta is equal to 0. Because if your numerator was equal to 0, then your whole fraction would also be equal to 0. Okay, so that's why, knowing your exact values can help you with your tan graphs. All right, so moving on. So these two tables are actually the same. So why did I put them in? I don't know. So let's just go back to the green box. Okay, so if we're just looking at a general graph of tan, so here we don't have any vertical transformations or horizontal transformations. A is a dilation factor, just as it is with the cosine and the sine graphs. Okay, A, even though it tells us the amplitude, it does also tell us the dilation factor for sine and cosine graphs. But with tan graphs, they don't actually have an amplitude because if you look at the red graph, it goes from negative infinity to infinity. Your range is R, whereas with sine and cosine graphs, you are restricted based on what your amplitude is. Now, N, actually I might just highlight this here. So we've got a dilation factor of A from the t-axis and a dilation factor of 1 on N from the y-axis. All right, so the following are important properties. Okay, so your N value, your N when we're doing sine and cosine graphs tells us your period. The period is 2 pi on N, but with tan graphs, it's just pi on N. Okay, so it's not 2 pi on N, it's just pi on N. So it does differ. As I said before, the range is R, so it's not restricted like it is with sine and cosine graphs. But on the flip side, its domain is not R. So for sine and cosine graphs, the domain is R because they go on infinitely. So does your tan graph, but because we've got those asymptotes, we can't say it's R because the values for theta aren't including those asymptotes. All right. But your asymptote can be found by using this equation. So just highlight your asymptotes. Okay, so the only thing you need to substitute in here is your value of n. So if we're just doing the general equation for an asymptote, you're just substituting in the value for n. Okay, so once you've worked out what n is, all right, so n being your coefficient of t, so in the first one it was 1, that would just be t equals 2k plus 1 times pi over 2. And you do have to say where k is an element of z. That is because our asymptotes keep going on forever. All right, unless you're restricting your domain, they will go on forever. So what the k is an element of z means k is equal to any integer. An integer. K equals integer. So it could be negative. You can have -2, -1, you can have 0, you can have 1, 2, and so on. So if we're using this general equation, we just need to substitute in values for k to see where restriction fits into the domain. Okay, so we'll do hopefully a few of them in a sec. All right, your x-axis intercepts. All right, at t equals k over pi n, where k is an element of z. So again, we're substituting in the value of n. And again, k can take on any integer, positive or negative, and also 0. Okay, so once you've found out your value of n, you can work out your period, you can work out your vertical asymptote, and you can work out your x-intercepts. Now, if your graph has shifted, all right, so if you've had a transformation, you need to consider, well, how has it affected my asymptotes and how has it affected my axes intercepts? All right, so let's have a look at question 3. Whoops. Just going to delete that for a bit. Sorry, I'm working out from before. Okay, so in question 3, we've got sketch the graph of each of the following for x is an element of 0 to 2 pi. So we're not actually including 0 and 2 pi. All right, so that's important. Now, with question A, we've got to identify the value of A, and the value of n is your coefficient of x. So we'll get started on question A. So the value of the value of A is 2. The value of n is 1. Now, the issue with this is that we can see it's in this form, y equals 2 tan x plus pi on 4. But the problem is when we were doing these not transformations, but we're looking at the asymptotes and the x-intercepts, it was for this equation. So A times tan of nt. All right, there hasn't been any vertical or horizontal transformations. So what we do is we look at it without the transformation first. Okay, so let's look at it as y equals 2 tan x. We can think about what the asymptotes are and what the x-intercepts are, and then we can apply the transformation. So pi on 4 means that we've gone to the left, pi on 4. All right, so we'll sketch the graph of 2 tan x first, and then we'll shift everything to the left, pi on 4. So we're going to take away pi on 4. All right, so first of all, your period. So it's probably the easiest one to do. Remember the period for tan graphs is pi on n. So for this one, it's just going to be pi. Your asymptotes. All right, and I can never remember the formula, so let me just go back up. 2k plus 1 pi over 2n. All right, and I'll talk about what we need to do there in a sec because I'll do the x-intercepts as well. All right, so your x-intercepts are at k pi on n. Now, I wonder why we've got k pi. Yeah, so just, you can see here they haven't got divided by n, so k pi on n. That's probably because we're just looking at a tan graph here. All right, whereas this one we're looking at a and n. So just make sure you're referring to this information when drawing your graphs. All right, so k pi on n. All right, so our value of n we worked out is 1, so it's going to just be k pi. All right, so with our asymptotes, I might write this in a different color. We're just going to substitute in different values of, oops, I haven't, let me just finish that off. So 2k plus 1 times pi, so n is equal to 1. All right, so for this one, let's substitute in different values of k. So k doesn't have anything to do with your domain, doesn't have anything to do with your range. Okay, you just put in different values of k and then you see what fits into your domain. Okay, so we can always start at k equals 0. I always think that's a good place to start because it's easy to substitute in k equals 0. So when k equals 0, we're going to have 2 times 0 plus 1, which is just 1. So we've got an asymptote at pi, at x equals pi. All right, so that's one, well, our asymptotes are going to shift, but let's just keep going. K equals 1. So we're going to have 2 times k is 2 plus 1 is 3, so 3 pi. So x is equal to 3 pi. And that might, no, that's not going to change when I substitute that in. So we've got k equals 0, k equals 1, and let's do, I'm going to keep that for now. Let's substitute in k equals -1. So when k equals -1, we're going to have 2 times -1, which is -2, plus 1 is -1, so x equals -pi. I'll probably need to write that again. All right, so remember we're only going from 0 to 2 pi, so we don't really need that many asymptotes anyway. All right, I'm just wondering whether we do the transformation now or the transformation later. We'll do the transformation in a sec. Let's look at the x-intercept. So when k is equal to 0, x is equal to 0. All right, so that's your first x-intercept. When k is equal to 1, x is equal to pi. And when k is equal to 2, x is equal to 2 pi. And we probably don't need to go any further. Now, with this transformation here, oh, what are you doing, green pen? All right, with this transformation here, we do have to shift all our asymptotes to the left by pi on 4 and all our x-intercepts to the left by pi on 4. Sorry, girls, I just realized I made an error. And I realized I made an error. I don't know whether you noticed I paused when I noticed I had 2 x equals pi's. So I had to go back and check my asymptote formula. I should have had a 2 there. I apologize. So I'm not going to edit the video because I've gone too far. So I'm just going to divide this by 2. It's actually not going to be that bad. We're just going to have to divide everything by 2. So here we're going to have on 2. This one's going to be on 2. And this one's going to be on 2. All right, not a big deal. But now I've realized where my error was, because you can't have an asymptote and the x-intercept the same thing, because an asymptote goes against an x-intercept. All right, so with our transformations, what we need to do with each asymptote, so I might do this down here, and I have not left myself enough room to draw these. All right, so your first, now this doesn't mean it's going to be our first asymptote. We do have to check whether it fits into the domain. All right, so remember we're shifting to the left by pi on 4. So I'm going to subtract pi on 4 for each one. But just to make that easier, I'm going to write all my asymptotes with a denominator of 4. So the first one being pi on 2, I'm going to change that to 2 pi on 4. And then we subtract pi on 4. So that's going to be 2 pi on 4 minus pi on 4 is just pi on 4. So I've written equals. The next one is going to be 3 pi on 2. So we're going to write that as 6 pi on 4 minus pi on 4, which is equal to 5 pi on 4. All right, so the third one I've got written here, negative pi on 2. Now, if I subtract pi on 4, it's going to be with outside our domain. All right, so we want to be between 0 and 2 pi, so I highlighted that up the top. But I'm looking at these, and we've got pi on 4, and we've got 5 pi on 4. I should really check if there's another one in the domain. So let's check for k equals 2. All right, so when k is equal to 2, I'm going to have 2 times 2, which is 4, plus 1 is 5. So x is equal to 5 pi on 2. So let's see if it fits into our domain. So 5 pi on, whoops, let's do it with a denominator of 4. 10 pi on 4 minus pi on 4, and that is equal to 9 pi on 4. Okay, so is that in our domain? So if you're unsure, just change your domain so it's also as a denominator of 4. So 2 pi on 4 is actually the same as 8 pi on 4. So 9 pi on 4 is out of our domain, so I can cross that off. Okay, so we've just got 2 asymptotes. Let me just get rid of question 4 for a sec. All right, so our x-intercepts, we do the same thing. All right, so we've got 0 minus pi on 4 equals negative pi on 4. All right, so I already know that's outside our domain. Cross that one off. The second one, we've got pi, so 4 pi on 4 minus pi on 4 is equal to 3 pi on 4. So that's a goodie. It's within our domain. And then the last one, we've got 2 pi. So I'm going to write that as 8 pi on 4 minus pi on 4 equals 7 pi on 4. And that is also in our domain. Okay, so I've got my 2 asymptotes. I've got my x-intercept. So let's sketch our graph. Actually, there's 2. We also have to think of our starting point and our end points. All right, so our end points. Okay, because remember we are restricted. Okay, so our first one is going to be at x equals 0. And at the other end, we're going to have x equals 2 pi. So we just need to substitute them back into our original equation. All right, so 2 times 10 210, 0 plus pi on 4, so just pi on 4. And tan of pi on 4 is 1 from memory. Oh, is that the only one I can remember? Is 2. I wonder if I have remembered that correctly. And y equals 210. 2 pi on, so we're going to have 8 pi on 4 plus pi on 4. What is that? 210. These are taking forever. 9 pi on 4. What is 9 pi on 4? Oh my gosh. So I'm just doing I'm just thinking of the unit circle in my head. So that's the same as 0 plus pi on 4. All right, cool. So that's also equal to 2. All right, so my knowledge of the unit circle, I just quickly thought about this in my head. So there's 2 pi plus pi on 4, all right, which is the same as 0 plus pi on 4, and pi on 4 is 1. So again, it's 2. Okay, so our endpoints are going to be, let's write them over here, 0, 2, and 2 pi and 2. Let's get rid of question 4. All right. Okay, so now we can finally sketch it. Now, I don't really think you're going to have to sketch this from the start. Look how long it is. You can just, actually, I have seen a tan graph, so I might actually check out what it's actually asking you in an exam. All right, your asymptotes. So all our denominators are pi on 4. So let's just go to 2 pi, and there's pi on 2, and that's 3 pi on 2. And then let's just separate them. So we've got pi on 4, etc., going up by pi on 4 each time. So it's pi on 4 there. 2 pi on 4, 3 pi on 4, pi, 5 pi on 4, 6 pi on 4, and then 7 pi on 4. All right, so let's do our asymptotes first. So our first asymptote is at pi on 4 and then 5 pi on 4. Pi on 4. All right, our x-intercepts are at 3 pi on 4, so here. And you can see they're halfway between your asymptotes as well. So I probably should do that in a different color. Do that in yellow. All right, so there's our x-intercept there, and our other x-intercept is at 7 pi on 4. All right, we haven't had any reflections, so my graph, all I need to do is sketch it like a tan graph, but I do need to take into consideration these endpoints. So 0, 2, so I might just write 2 here. All right, so at 0, 2, I should have an open circle. I'm not going to. Let's make it a bit smaller. All right, need an open circle because it's not included at 0. Okay, so remember, go back up to the start. We're going from 0 to 2 pi. So an open circle because 0 and 2 pi are not included. All right, so let's do the middle one first because that's probably the easiest. So you just do the shape of a tan graph. Kind of looks like a cubic in a way. All right, and that means for the left side of this asymptote, now you can't see my arrow, but we can kind of see that it would keep going up like that. And then on this side, we've got to do our other endpoint. So 2 pi and 2, I've got another open circle. Oh gosh, that is terrible. Try that again. And my dog is behind me shaking. Let it go. Oh gosh. All right, so there's your tan graph. It's a very poorly drawn one. But from drawing that, you can see how to get your asymptotes, how to get your x-intercepts, your endpoints, and that's really all you need when sketching. All right, I'm going to do another one and just end this video on question 3 because these are very complicated. As I've said, you can do them on your calculator. So I might just make a little bit more space for myself. And then I feel like this video, girls, is not the most exciting video either. I apologize. All right, let's see if I can redeem myself with this one. All right, so we've got y equals 3 tan 2 y equals 3 tan 2x minus pi on 4. I'm pretty sure that's what it is. All right, so let's go and do it without that horizontal transformation. Okay, so we're going to do it without the transformation. So basically this graph is the same as y equals 3 tan 2x. Oh, just realized what we needed to do, sorry, is we do need to, oh no we don't. Sorry, I was just thinking expand that bracket, but no, we don't need to do that. So we're looking at the graph of 3 tan 2x, all right, and then at the end, with our asymptotes and our y-axes, we're going to shift it to the right, pi on 4. So just make sure that your equation is in that form with the bracket, that your coefficient of x is taken out. Okay, so it was already taken out for me. That's what I got a little bit confused about before. Okay, so your value of a is 3. Your value of n is 2. And we're going to do the period is pi on n. So for this one, it's going to be pi on 2. Now your asymptotes, let's see if I can remember the formula. Oh my gosh, 2k plus 1 pi over 2n. I think I might just have to go and double check that. And the x-intercepts are at k pi over n. Okay, let's just check if I've got those two correct. All right, I'm going to look at the green box. 2k plus 1 to n. Yes, k pi on n. Awesome. All right, so let's do the asymptotes. All right, sorry, I just made a big mistake, and now you probably realize the screen slightly changed because I didn't delete everything I just did, but you don't know because I deleted it. But I'll tell you the error I did, and I can just see that should be an n. I let n equal pi on 2 instead of 2, and then I got to the end and I was like, why is this not working? And then I realized I substituted in for n pi on 2 instead of 2, so just be careful. It is quite late, girls, while I'm doing this video, so probably not a good idea for me to do that. All right, so if n is 2, then 2 times 2 gives us 4. Okay, so that's a bit better. All right, and then for your x-intercepts, we're going to have k times pi on 2. Okay, so n is equal to 2, so we're just substituting in for n and n here. All right, so let's do the asymptotes first. Scroll down a little bit. So remember, when we're doing the asymptotes, we need them to fit into our domain, which is 0 to 2 pi. So we're just looking at different values of k. All right, so we've got 2k plus 1 times pi over 4. So let's just do k equals 0. So when k equals 0, x is equal to pi on 4. All right, when k is equal to 1, we get 2 times 1, which is 2, plus 1 is 3, so 3 pi on 4. And now I know if I do k equals 2, oh, we'll do, let me just think off the top of my head. Let's just do k equals, yeah, I think k equals 2 will still be in our domain. So that's giving us 5 pi on 4. I'm just wondering if I do k equals -1, I might just do that for fun. Because this is a real hoot. I'll do that over here. K equals -1. So -2, so we've got negative pi on 4. Okay, so there are our asymptotes without the transformation. Okay, so remember the equation we're doing. We've got to shift it to the right, pi on 4. So all our asymptotes we need to add pi on 4 to. So we're going to go plus pi on 4, plus pi on 4, plus pi on 4, and plus pi on 4 for this one. And I might just write them over here. So we've got asymptotes at x equals, all right, so pi, actually we'll start with the negative one, probably good to go in order. So negative pi on 4 plus pi on 4 is 0. Even though that's outside our domain, we can still sketch it because it's an asymptote. It's not actually a part of sketching the curve. So it's probably good to put that asymptote there. Then we've got pi on 4 plus pi on 4 is 2 pi on 4, and I'll just leave it as its unsimplified fraction. 3 pi on 4 plus pi on 4 is 5 pi on 4. And then 5 pi on 4 plus pi on 4 is 6 pi on 4. Now we can't go any further than 8 pi on 4. So let's just see what happens when we substitute in 3. So we're going to have 7 pi on 4. 8 pi on 4 is also going to be 1. All right, and I'll show you in a sec. Sorry, I just did that in my head. But if we let k equal 2, x is going to equal, so 2 times 2 is 4 plus, not 2, 3, sorry. K equals 3, 2 times 3 is 6 plus 1 is 7, 7 pi on 4. And then if I add pi on 4, I get 8 pi on 4. So there's all my asymptotes. All right, and let's do our x-intercepts now. Okay, so x-intercepts is k pi on 2. All right, so you can do k equals 0, x equals k pi on 2, so 0. I'm just wondering what happens when I do k equals -1. I'm going to have x equals, so I'm just substituting it into k pi on 2, your x-intercept up the top. Oops. So negative pi on 2. When k is equal to 1, we get pi on 2. When k is equal to 2, we get pi. When k is equal to 3, we get 3 pi on 2. When k is equal to 4, we get 4 pi on 2, which is 2 pi. So I'm going to stop there. All right, so now we need to do our shift. So we're going to add pi on 4 for each one. So plus pi on 4, plus pi on 4, plus pi on 4, plus pi on 4. This is exhausting. Plus pi on 4, plus pi on 4. Okay, so let's do our x-intercepts. Okay, so I'm going to start with k equals -1, so we can just write our x-intercepts in order. So negative pi on 2 plus pi on 4, so that's -2 pi on 2, so that's not going to be 1, so I'm just going to cross that one out. Then when x equals, for k equals 0, x equals 0 plus pi on 4, so pi on 4 is going to be our first one. Then when k equals 1, we've got 2 pi on 4, so 3 pi on 4. And then for x, we've got 5 pi. Did I make an error there? Because I'm going to have an asymptote. Oh, let me just think about, I think I may have made an error with k equals 2. All right, I'll come back to that one. I think I made the error on my asymptotes Yes, I did. So it should be 4 pi on 4. Here we go. The reason I knew that, girls, remember, they can't be the same. Your asymptotes and your x-intercepts can't be the same. There we go. That makes sense. And you can see they're going up by 2 each time. All right. X-intercepts, so pi on 4, 3 pi on 4, 5 pi on 4. You can kind of see a pattern, 7 pi on 4. And remember, your x-intercepts are halfway between your asymptotes as well. So unless you've got a horizontal shift, okay, so you can see we're halfway. So there are our x-intercepts. All right, and then let's do our endpoints. All right, so when x equals 0, we're going to substitute y into our, substitute x equals 0 into our equation. So y equals 2 tan 0 minus pi on 4, and x equals 2 pi, y equals 2 tan 2 pi minus pi on 4. So that is equal to negative 2 tan pi on 4. And then we have, actually, yeah, I think that's fine. So I might just erase that for a second because I think I'm getting a little bit mixed up. So tan, 2 tan, negative pi on 4. All right, so tan pi on 4 is 1, and we're in the negative quadrant. So it is negative 2. All right, and this one's the same. Cool. All right, so with our graph, nearly there. We'll make it long. All right, so there's x and y. All right, we'll put in 2 pi at the end. And we're also going up by 4 this time, so we'll do the same axes as before. So pi on 2, pi on 4, 3 pi on 4. What have we got? 5 pi on 4, 6 pi on 4, or 3 pi on 2, 7 pi on 4. All right, so let's draw our asymptotes first. So our asymptotes are 0 and going up by multiples of 2. There's our first one. All right, so there's all our asymptotes. I might do the graph in pink. Okay, so we're going through, halfway point is our x-intercepts. All right, we do need to put in our endpoints. So our endpoints are going to be at negative 2, so down here. We didn't need to do it that low, and down there at negative 2. So when I'm sketching, and it's an open circle, so it doesn't matter that it's on the asymptote, okay, because it's not included. Okay, there we go. And we don't even have to include that circle there. But it might be a good idea to put it on there anyway. All right, so I'm going to leave it there, girls, with the graphs, and I'll do a separate video for solving tan equations.